हेलो दोस्तों, मेरा नाम अनिल कुमार सिंह है। चलिए आज मैं आपको थ्योरी ऑफ सिमिलरिटी के बारे में बताऊं। थ्योरी ऑफ सिमिलरिटी। सिमिलरिटी मीन्स होता है समरूपता, और आप कह सकते हैं इसको कॉपिंग भी कह सकते हैं और एनालॉजी। थ्योरी ऑफ सिमिलरिटी, कॉपिंग या एनालॉजी, ये आपको ये चीज बताती है कि कैसे एक प्रिंसिपल निकलता है तो उसके द्वारा दूसरा वैज्ञानिक, जैसे एक वैज्ञानिक ने अगर कोई इन्वेंशन किया तो दूसरा वैज्ञानिक उस इन्वेंशन को कैसे अपने फील्ड में कॉपिंग कर लेता है। कॉपी का मतलब है उसके सिमिलरिटी आती है कि क्या चीजें होती हैं, ये हम लोग जानेंगे। What is theory of similarity says? Theory of similarity actually tell us कि how one person describe या invented a principle and another person, another scientist who catch their principle and applied in his field to get theory of similarity, copying and analogy. Now today I will explain you briefly. Carefully understand it. Suppose conservation of mass, conservation of energy, conservation of momentum, most important. You know about conservation means energy can neither be created or not destroyed. What is conservation means? Conservation means energy can neither be created nor destroyed. It can convert into first form into second form. Now, conservation of mass means if A change B, the mass of this substance is and the mass of this substance are both are equal. Example, H2 plus O2 equal to 2H2O. Now, in conservation of energy means there are two types of energy, potential energy plus kinetic energy. Both are constant. In conservation of momentum, momentum of one body equal to momentum of second body. Now, this is the mass of an object and this is the second mass of an object. When its velocity after impact v and the velocity after impact vt. Then the momentum of mass m1 and the momentum of after. So, conservation of mass and conservation of energy and conservation of momentum both are similarly. If one person can describe it, then second applied to the energy in the field of momentum. You can see. Now, you can see the conservation of energy. So, theory of similarity means conservation is applied in every field. Momentum, energy and mass in further. So conservation is applied in theory of similarity. Now, in the field of different things, in the field of now in the gravitational force and Coulomb law, both are same in the different fields. Now you can say the mass of this planet M1 and the mass of planet M2, both are different in the distance r. Then the gravitational forces, you know all about M1 M2 upon r square. In the field of Coulomb, charge, positive charge, both are distance charge, Q1 and Q2, distance between r. Then force is equal to Q1, Q2 and r. So now you can see the theory of similarity, gravitational force and Coulomb's law, both are similar. If first person, Newton thinks a gravitational force applied to attract a planet like Earth and Sun. Sun attracts Earth attracts Sun. Suppose this is Earth and this is Earth. This is Sun and this is Earth. Both are attract. Now Coulomb in the field of charge. You know all about the positive charge and the negative charge. In the field of, Coulomb thinks in the field of charge. And this person, Newton, in the field of planet, mass, which person has a mass, apply gravitational force, which which body has charge. It can follow the law of Coulomb law. But you can see the formula. Both formula drive in the same, but the quantities are different. Now, you also see this is our solar system. You know, Sun, Mercury is the first planet. Mercury, Venus, Earth and Mars. This is our solar system. You think Sun, planet. If Sun is positive and planets are negative, Earth is also negative charge. So in the field of theory of similarity, you think now in a nuclear, atom, most atom. You also know about this is nucleus and these are the electron. Electron has the charge and nucleus has positive charge. So this is a similarity inside atom. Imagination. This is the inside view of an atom. The sun is in the middle, in nucleus, and these are the planets like this is a planet, sun-like nucleus, and these are the stars. Stars means a planet, negative charge. Both are travel in the field. So that is the similarity. Solar system explained in the small view, just like a structure than the biggest. So I think the solar system, which has the structure, the atom has already in the structure, but atoms are very thin. We can imagine it. So that is similarity. Now you can see sound, sound and electromagnetism wave. You know all about sound is a disturbance. Sound is a disturbance, a disturb, a vibration. But sound only our ear can hear kilohertz or greater than these kilohertz. Greater. It can ultrasonic. You also know about in my lecture. Inaudible, audible between this and this is ultrasonic wave, UV. In electromagnetic wave, similarity Oersted give a principle when a wire flow electricity I, it produces a magnetic field. Faraday thinks this opposite. If a wire when magnetic field are going outside this wire produce an electricity and electromagnetic waves. I think I remember the name of who discovered Maxwell. Maxwell thinks if we change alternately current, a magnetic field, so it produces a electromagnetic waves. You also know about this is the wave perpendicular, and this is also in the perpendicular wave. Suppose this wave u travel and this wave u means. So if we change electricity and if we change the magnetic field, both disturbance produce electromagnetic waves. This is called a sound wave. Means this is natural sound. Our vocal produces sound. That is a sound. But in our speaker, mobile phone, and I talk to you, this is reached by the electromagnetic waves, the disturbance. So think similarity. This person thinks positively, Faraday thinks negatively, and this person thinks both are disturbance, and it produces the magnetic waves. So that is the similarity. Sound waves are the natural thing, disturbance, but this is produced by the current, by electricity. So that is electromagnetic waves. Now you can shock when you think कि our this is the tower, mobile tower. Mobile tower is a sound produced device, but this frequency are higher sound produced. Suppose someone else in your room, someone shouting loudly, you can hear this sound, but think a person who shouting greater 20 kilohertz frequency, so you cannot hear. So tower speak loudly in electromagnetic waves. Electromagnetic waves. This is a sound wave which is produced by electricity. So means our vocal is produced naturally sound, and in the field of science electromagnetism, a sound is a electromagnetic waves. Do not confuse electromagnetic waves with the light wave. Light wave has a dual property. It is a quantum phase mechanism and a electromagnetic wave, the dual character. It cannot be described by our scientists briefly. There is a paradox. Electromagnetic waves. I think electromagnetic waves are sound waves. Now, electromagnetic waves, in the field of electromagnetic waves and the quantum physics, in quantum, what is quantum? Quantum and radiation in similarity. Quantum means energy travel in the form of particles. Radiation, you know about Earth and Sun, light reach from Earth by the radiation. So what is quantum and radiation? Both are similar. This is the energy travel in the form of particles. Suppose this is a hot metal, like temperature 3000 degrees. Where this metal, iron, anything you can choose, cooled by air. So higher temperature leaps in energy in a packet faster than temperature 2000 degrees. It's slow. When temperature 1 degree 1000, it's slow. And when log 5 degrees centigrade, so its gap between energy particle is larger. So that is a quantum physics. In radiation, the energy means energy in radiation is travel in the form of waves, light waves, not in quantum physics. And in quantum physics, radiation both are same. In the field of similarity, one person describes things. Radiation is the form of this. You can see the higher temperature wavelength is small. Means this wavelength, this is the wavelength, larger wavelength, lambda, less there, wavelength is less, higher temperature less than, just like a hot, like a sun. You can think this metal is like a sun. Sun has the different radiation is both are same. So you can analogy radiation in quantum. There is a lot of combination. Now, similarity, if Newtonian mechanism and relativism mechanism, both are same, Newtonian and relativistic. If your speed is less than 3 into 10 to power 8 meter per second, and speed is less than light speed, you follow the Newton's law, like a F is equal to ma, P is equal to mv. You follow the law of Newtonian mechanism. But when you got the speed of light, so you follow the Einstein's law. P is equal to m0 under root v square minus c square. Into P मान सकते हो, F भी मान सकते हो. So you follow the relativistic mechanism. So that is the similarity. Newtonian mechanism is applied because always you know about our spacecraft किसी में 18 किलोमीटर पर सेकेंड speed. If we got the speed of light, so our mechanism, the Newton's fail. When you got the speed of light, a less speed, then fourth power of speed light, second power of speed of light. So where relativistic mechanisms are applied, your all physics fail. In this, Newtonian mechanisms are not followed by anybody, but relativistic mechanisms are followed, where formula are similar, but these formula are changed by like this. So that is the theory of relativity and relativistic mechanism and the Newtonian mechanism. Both are different. In the field of Earth, you can apply when you got the speed of light, you can relativistic mechanism. This is further extraordinary. In our classical physics, you apply Newtonian mechanism. Both are similar. Einstein thinks if we got the speed of light, suppose Pf is equal to mv upon t. Einstein thinks if we got the speed of light, our velocity always is same. That is the thinking of relativistic mechanism and Newtonian mechanism. Now, also now in black hole and our sun, what is the difference? Black hole and what is the black hole? The gravity Gravity. G. You know about the gravitational force and the gravitational force. In black hole, the gravitational force is maximum. But these are only minimum. Minimum means depend on the size. Depend on the size. In the mobile, we use black hole like it. Black. I use the black pen like a black hole. Black hole means this is black. And this is sun. But in the black hole, the gravity is maximum. So the light waves are going, they are not reflected. If light waves are not reflected, suppose a light wave which has a speed 3 into 10 to power 8, that means these waves are not reflected. It is catched by this. So no light wave reflected. So this will show us black. If this is my tube light reflected by me and you can see this. If no light is reflected, I switch on the light, you can't see it. So where light waves are reflected, it is absorbed by this planet. Suppose black hole like a planet. If our sun are maximum gravity, the light waves are not reflected. It can bounce by this, so it becomes a black hole. So black hole means black planet. Black hole means a planet who has gravity as the maximum point. No one can escape from me. And in this, you can escape me. So where black hole means a planet, black hole means a planet which has maximum power of gravity. If you like understand, if anybody doubts, I will teach you wrong things. So please comment me. I will improve. This is my personal point of view. I will explain of all of you. Not, I think I made a video for you. If someone helps my video, this thing, you can better understand it. This is my personal thing, the theory of similarity. I think that if you like, please comment me. What is the mistake made by me? You can tell me by the comment. I improve this and I make a better video for you. Thank you very much, my friend.